Well, friends, Dr. K.K. Chawla is again before you to explain the second type of assignment problem known as maximization case. Hungarian assignment method is there that has been developed by DeConnick, but originally that method was developed for minimization. For maximization, we cannot start directly from our first step of row reduction. We have to convert this maximization case, that is profit, to minimization case, that is cost, or you can say opportunity cost. So we have to convert, and there is only one technique, that subtract all the elements of the given matrix from the highest number. I repeat, subtract all the elements of the given matrix from the highest element, and you will get the optimization method of solving assignment problem in the same way as in case of minimization. So let's do that. The given, I have taken this exercise. This is maximization profit. Now we have to select the highest number. Highest number is 41. Now you have to subtract all the numbers from 41. All the numbers from 41. We get 41 minus 32, 9, 3, 1, 13 and 1. Again 1, 17, 13, 20 and 5. 41 is the highest number, so 41 minus 41 is 0, 14, 41 minus 33 is 8, 11 and 4. 41 minus 22 is 19, 3, 0 and 5, again 5. Now 12 is here, 8, 1, 6 and 2. So this is the technique of converting maximization case into minimization case by subtracting all the elements of the given matrix of maximization from the highest number, and we get this as minimization case. Now we will apply Hungarian assignment method as earlier we have discussed. Again, step number 1, row reduction. So very clear, we have to select a minimum element from each row and subtract that minimum element from all the elements of that row. Similar in case of column. So first taking the row reduction, 8, 1 is minimum, 2, 0, 12, again 0. Second row, again 1 is minimum, 0, 16, 12, 19, 4. In third row 0 is there, so no need for further reduction. 0, 14, 8, 11, 4. In the fifth row again there is a 0, so 19, 3, 0, 5, 5. And in the last row again 1 is minimum, 11, 7, 0, 5, 1. So after row reduction, next step is column reduction, selecting minimum element, and from the each column, from all the elements of that column, and if there is 0 or zeros, no need to change. So 8 0 0 19 11. Second column, minimum is 2 0 14 12 1 and 5. Third column, zeros are there, 0 12 8 0 0. In the fourth column, minimum is 5, so 7 14 6 0 0. And in the last column, 0 is already there, so 0 4 4 5 1. This is your column reduction. After column reduction, you have to go for making assignments. Same technique. Let me repeat. Find the row in which there is a single 0. Mark that 0 as assignment and cross all other zeros in that column. So first row, 3 zeros. Second row, 1 0 is there. Mark that 0 as assignment and cross other zeros in that column. So third row, no 0. Fourth row, 2 zeros. Fifth row, again 2 0. Now come to the columns. So first column is there, assignment is there. Now in the second column, single 0 and delete cross all other zeros lying in that row. Now in the second row, assignment is there. Third row, no assignment, no 0. And fourth row, again 2 zeros are there. And fifth row, again 2 zeros are there. Column wise you can check. Again 2 zeros are there. So we have to make assignment. At least here the assignment can be either this or this if row wise, or this or this. So take any choice. Take your first choice. That is better. Take your first choice. If you mark row wise and mark this as 0 assignment, then cross that 0. Now you can cross again, row is there. Now fifth row, again you have to mark this as assignment and cross this 0. So we have got 4 assignments, but we require 5 for optimum results. So now we have to go for, after making assignments, if the number of assignments are not equal to number of rows or columns or jobs or machines, then we have to go for marking. And this marking is very important step. How to mark the rows and columns? Then find the row in which there is no assignment, or you can say mark that row in which there is no assignment. First row assignment is there, second row assignment is there, third row no assignment. So mark that row. Mark the row in which there is no assignment. Now find the zeros in the marked row. Find the zeros in the marked row. This is the marked row and here is the 0. Then you have to mark this as column. So second step is mark the column in which is the 0 in the marked row. Now third is, when you have marked the column, then find the assignment in the marked column. Find the assignment in the marked column and mark that row in front of that assignment. So there is assignment in the marked column. So mark this row. Now after this, find the 0 in the marked row. This 0 is there marking is there. Again, assignment is there, marking is there, means further marking is not possible. You have to make it sure by repeating the process. 3 points you have to remember. One is, find the row in which there is no assignment, mark that row. Find the 0 in the marked row and mark that as column. Then find the assignment in the marked column and then mark that row. Repeat it till further assignment is not possible. Now, drawing the lines. Only one line you have to remember. When you have to draw the lines through unmarked rows and marked column. Draw the lines through unmarked row. This is your unmarked row. This is your unmarked row. Again, unmarked row. Draw the parallel lines through unmarked rows and marked column. And this is your marked column. Now, you have to make it a fresh table. So here, we will make another table as fresh table, and the technique is same. Select the minimum element from the uncovered element, and that element is 4, and subtract this 4 from all the uncovered elements and add it to the elements lying at the intersection of the two lines, and other elements which are simply covered are not to be touched. So selecting minimum element, and this minimum element is 4. Now start your process. 8 is at the intersection of two lines. It will become 12. 8 plus 4. This is 0. This is 0. 7. Again 0. Second row, 0 is simply there. 10. 8. 10. 0. Again 0, 8, 4, 2, 0. Again here is 19. So you have to add 4. This is not at the intersection line, so it is simply 19. Oh, it is at the intersection of the two lines. So it is 23. Now 1, 0, 0, 5. 11 plus 4. Again 11 is at the intersection of two lines. 11 plus 4, 15. 5, 0, 0 and 1. Now you get the new table, and at this table you are to make assignments. Again repetition. Make assignments with the same way, same method. So find the row in which there is single 0. 3 0, 2 0, 2 0, 2 0, 2 0. So row wise there is no even a single row having single 0. Then we have to go for column. First column 2 0, second column 1 0 is there. Mark this 0 as assignment and cross 0 in the row. Then third column 2 zeros, fourth column 2 zeros, fifth column again 2 zeros. Now come to again second row, again 2 0, third row 2 0, 2 0, 2 0. Now again we have stuck. So it means there is a alternative exists. As making assignments, there is an alternative. So again, if you are coming row wise, then in the second rows there are 2 0, then make either this 0 as assignment or this 0 as assignment. It will not affect the result, let me tell you. So row wise, if 0, you make this assignment as 0 row wise, then delete the zeros in the column. Then here also you can delete, because there is no possibility of 2 assignments in one row or column. So this you can delete also. In the third row, now this is the single 0 and you have to delete in the zeros in the other column, otherwise this would have been deleted at this time. Now again, in the fourth row there are 2 zeros, fifth row 2 zeros, third column 2 0, and fourth column 2 0, and still we require 2 more assignments. Again here an alternator. So there is very likely that possibility arises when you are stuck, but you are to make an alternative choices, then it is always better to have first choice in the row wise assignment. So if we go for row wise, either this or this, make it over here, cross and cross this, then only 1 0 is left, then crossing it. Now there are 5 assignments and we got the optimum solution. How to write down the answer then? Optimum solution means that the answer we will be getting cannot be further improved, cannot be further increased or decreased. That is called optimum solution. So you can write down like this: since number of assignments are 5, hence we get optimum solution. We get optimum solution. So how to write this solution or the answer? So we will be writing like this: job, machine, and profit. From the last table where you have got all the assignments and number is sufficient, that table shows one job, first job should be assigned to second machine, job 1 to machine B, job 1 to B, job 2 to A, and job 3 to E, and 4 to C, and 5 to D. This is a sequence you can say, or the assignment you can say, and the profit you have to see, check from the original table of maximization profit. 1A. So profit is in rupees, that is 32. 1B, profit is 38. 2A, profit is 40. 3E, profit is 37. 4C, profit is 41. And 5D, D is 35. So this is your maximum profit you will be getting, and the total profit will be total profit 8, 7, 15, 16, 21, 2, 5, 9, 12, 16, 191 rupees. And this is your optimum solution. So this profit cannot be further increased. So this is the technique. The difference only between assignment problem and the maximization problem is minimization and maximization is the technique is the same, but we have to convert the maximization problem into minimization problems. So that is I have to tell you about this type of assignment problem, that is maximization problem. So thank you very much. If you like, kindly like my video, subscribe and like my videos. Thank you very much.